Hello, welcome to Build Time, the show where the Android team talks with Android developers about building great apps. My name is Christopher Cartland. Today, I'm joined by Nam and Carmen, and we're going to have some really interesting conversations. Thanks for joining us today.
Thank you.
Thank you.
I'll let them introduce themselves and kind of what they work on in a little more detail, but I think we're going to get to some really deep, technical, interesting discussions if I know anything about them. And so, Nam, why don't you go first and tell us a little bit about maybe your full name, what you work on, and how long you've been working on Android.
My name is Nam Nguyen. I work on Google Maps performance. I've been working on performance for the past 5 years. And performance is always fun, so it's good to be here to be talking about performance.
Fantastic. Thanks for being here. And Carmen, again, full name and a little bit about where you're coming from in the Android world.
Yeah, my name is Carmen Jackson. I am on the Android platform performance team, so working on kind of the Android frameworks, all the underlying systems that run Android. I've been doing that for about 7 years, and before that, I was an app developer. So my area of interest is kind of bridging the gap between the Android platform and Android apps so that we can kind of both be successful together.
Fantastic. So I think we'll be talking about something related to performance. And Nam will provide maybe some context from the Maps team about how this affects them in their application specifically. And it's great to have Carmen here for insights from the Android team. So to start off, performance is a big area. There's so many things in performance. So is there any particular area that you think we should talk about today?
One thing that we've been thinking about a lot to help apps kind of do better, be more efficient with what they already have is DEX optimization, baseline profiles, and startup profiles. So the idea that we can take a look at what apps are doing and then optimize the apps or the system to do those things more efficiently. Kind of a general area we've been thinking a lot about because it tends to be really big performance payoff for not a lot of work. So we could start by talking about baseline profiles, which is a tool, a performance tool that's existed for maybe about a year or so. So you might have heard us talk about this before, where an app developer can record the methods and classes that are run during startup or during critical time periods of the app. Like if there's a scrolling list that's jank sensitive or something, they can record what is run during that time and then use the baseline profile to make sure that that's always compiled. And Nam actually kind of initially conceptualized this idea really early on. So Maps was a very early adopter of baseline profiles.
So Nam, can you tell us a little more about that? So we'll get to the other areas of optimization and performance later, but let's talk a little bit about baseline profiles. So from your perspective, why was this something that made sense for Maps to pay attention to?
Sure. So we saw the big performance difference between day one of a release compared to, for example, day 7 of a release. The gap was 40%. So when we release a new version, it would feel quite sluggish. But after about a week, it would feel faster. The thing is, we release a new version every week, so the cycle repeats. You would notice that the app would feel slow, and a few days later, the app would feel a bit faster. So that's where baseline profiles come into the picture. It tries to give day one. It tries to improve the performance of day one, so that you get on the day one of a release, you get a fast app right away.
Awesome. So that's interesting because you mentioned that it takes some time maybe for some optimizations to kick in. So this is actually probably baseline profiles are even more important for an app developer that releases frequently. But I do want to understand a little bit more. Why is it that this you can help something on day one that would have maybe eventually gotten there? What optimization is happening? Maybe Carmen, can you provide some context on that?
Yeah, so the way this works on the Android platform is that whenever you are using an app, we're kind of keeping track of which classes and methods are frequently used during your app usage. And so what Nam and what the Google Maps users were seeing was that when we first downloaded the app, we didn't have any recordings of the profile of the app usage yet. And as the
We being
users
the
would
Android,
yes, the Android
operating system.
platform, the Android operating system didn't know what methods of the app were going to be run. So we didn't have any ability to do pre-optimization on those methods. Then as the users would use the app over the course of that week, we would record the classes and methods that were run and use those as inputs to background compilation. So we would then be able to compile and speed up the actual running of the app for the areas of high usage. And so that's what we would actually see over the course of the week is we would see what classes and methods were being run. Overnight, usually, or when the phone is idle, we compile those methods in, which speeds up the running time of those classes and methods the next time the user uses the phone. So over the course of several days, we see how that individual person uses maps, make sure those code paths are optimized, and then they have a better experience. What Baseline Profiles does is gives the app developer the ability to provide, kind of precede that list of what the app developer thinks is going to be the common paths. And so then that gets delivered with your APK when it's downloaded to the device on day one, immediately compiled in, so every usage can start out optimized from the first one to the last one.
Fantastic. So if an app developer knows how their app behaves, they can tell the operating system what to optimize instead of letting the operating system over time figure that out. So Nam, we've been talking a little bit about baseline profiles. So what have you done to be able to help take advantage of these optimizations on day one?
Sure. Let me take a step back and add some color. So just-in-time compilation is really the enemy of startup performance. You want to avoid doing just-in-time compilation as much as possible. And that is what baseline profiles do. They reduce the need to do just-in-time compilation. And we have automated tests that generate baseline profiles. A baseline profile is comprised of two parts: a list of startup classes that gets loaded during startup, and a list of methods that get executed during startup. Those methods are hot or important, and they should be compiled. So we have automated tests that run do important critical user journeys and output those two files. When we build maps, we bundle all those files together, and then we ship it with our APK.
Okay, fantastic. And so you have those files that you generate and build. So now, is this something that, how do you generate them on your side? Is this something that like the Android team provides tools for? Or did you have to do something on your own?
So we were the pioneer of profiles. So we had our internal tooling. And eventually, they were adopted by Google and also the Android team. Carmen, do you want to add a little bit about that?
Yeah, so we saw that Maps was kind of doing their own homebrewed baseline profile implementation and realized how cool and useful of an idea that was. So then we on the Android platform tried to generalize that solution to something that all apps could easily use. So at first it was this homegrown solution that was kind of custom to the Maps app, but now any app can generate baseline profiles using the Jetpack Macro Benchmark testing library. So usually you would use Jetpack Macro Benchmark to run performance tests to see what your performance is, but that kind of clean configuration that the Jetpack Macro Benchmark library sets up for you is also the ideal configuration for collecting the baseline profiles of the user journeys that you care about. Often the user journeys that you care about are the ones you were going to test anyway, so there's a lot of, it makes it very convenient. So at the time that Maps started doing this using baseline profiles, these tools did not exist, but now we've put a lot of work into making it very easy for any app developer to do the same thing. So that's what we recommend for all apps in general, is to use Macro Benchmark to collect your profiles.
Now, help me understand something a little bit here, because we first started talking about how the operating system is able to kind of like understand apps and then optimize for them. But then we hear that Nam is telling us that the Maps team was able to kind of do some stuff on their own. So like, what does that mean for how, like, it sounds a little bit like there's like a who does what, because the app was somehow able to, without Android help, ship something information. Did they like give that to the OS, or did they sort of like mess with their own app behavior to be able to take advantage of these things even without the operating system doing something? It seems like a little bit of how did we get started before you start seeing some benefits?
Yeah, I'll talk about the platform half of it, and then Nam can talk about the maps side of it. But one thing the Android platform does, in addition to incorporating the profiles from an individual user into their own device usage the next day via background compilation, is it records those classes and methods that users are using and uploads them to the cloud. The Play Store then takes the aggregated kind of usage classes and methods from a large number of users, combines them together into kind of an average user's use case, and then delivers those to apps that are downloaded later on. At the time that we were originally thinking about baseline profiles, there was a pretty significant delay between collecting the profiles from users, incorporating them in the Play Store, and then redistributing them with apps. That time depends on the number of apps that have run the code. So it varies based on your usage, but is now a much shorter time, a much shorter turnaround. But long story short, the Android platform had systems for incorporating and compiling profiles that were provided, but we weren't necessarily getting those aggregated profiles for days after a new app version was launched. So even though we could apply a profile, we didn't have a profile to apply on the first, even maybe second or third day of use. But the systems were there to potentially use one if we had one. So that's where the maps kind of tricks came in to leverage those pathways.
Wonderful. Nam, do you want to tell us a little bit more about any tricks?
Yeah, so we noticed this issue where the aggregation took days for maps to deliver a good profile to user devices. So we thought long and hard on this problem and tried to find a way to work around this delay. And we noticed that we're able to give our profiles directly to the Android operating system. So this was not a published API. We just had access to that profile directory. So what we did was we just copied our list of important classes and methods into that directory, and Android would just pick up that file.
Fantastic. So you just looked around in the Android framework and realized that you could put some files here, and then Android would pick it up and optimize your app more effectively.
Right. And then we saw about a 20% speed improvement just by doing that.
Oh, wow.
Yeah, and I will jump in to say that the way that Maps was able to do this moved the incorporation of those profiles much earlier to the user's time using Maps, but it wasn't able to quite move them to the very first Maps app launch, right? The new version of Maps would still need to launch, put these profiles in the platform location, and then wait a short period for them to be incorporated. When we kind of graduated baseline profiles to a platform feature, we were able to ship them. Part of being able to download them with your APK in the Play Store included being able to compile them before your app is launched even the first time. So, which I mostly mentioned to say, using the regular baseline profiles channels is still better than doing this hack slightly. We don't actually recommend manually applying your profiles because we've now been able to promote this feature to a platform supported first party feature.
So there's a little bit more to that hack actually. We can actually tell Android to compile maps right away. So that was another issue where they did not check for permissions at all. We can compile maps anytime we want. Every hour or so, yes, we can just compile the app. But the thing is, like once we told Android about this, they quickly patched this loophole. So if you want fun things, keep it to yourself. That's the moral of the story.
Well, thank you for telling us, and I'm glad that the Android team was able to, do things the right way going forward. But what I really love about this is how much back and forth there was, because it seems like that the Android team recognized something that could be optimized eventually, and it took some time to get there. The Maps team realized that we can actually make it a little better by providing the information up front, and then the Android team took that again the next step. Oh, Maps is making it better earlier. We can do it even better by having it available on the first app launch. And so I can see how we've ended up in a nice conclusion here. But it kind of took multiple parties and took the operating system itself and the app developer team to kind of like get to the final situation where we are today.
Mm-hmm. Well, it was really a situation of we knew a good idea when we saw it on the Android platform side. We were like, oh, yes, you're doing this. This is awesome. Everyone should do this. How do we make it so that everyone can do this? So, yeah, it was such a cool and impactful thing to do that we wanted to make sure everyone could. And like Nam was saying, you initially saw really big improvements to your startup time, right? Like 20% in some cases, I think you said, in those worst case first launch scenario.
That was with the initial version, but with based on profiles, we were seeing close to 30%, 35% improvement because on day one, we are getting the best profile we can get delivered to our users right away.
So cool. And I definitely want to like kind of make sure people are hearing that number because this is for some apps, right? This is a situation where if you can set up your an automated infrastructure to collect those profiles and then build those into your app releases, and you even get pretty big benefits with a slightly outdated profile. You could do this occasionally manually and improve your first day launch performance pretty dramatically. So something very cool to keep in mind as again, to go back to what we were saying before, as a performance benefit that you can get using the app that you've already written, right? Using kind of just a kind of one time or one kind of piece of work that will continue to provide that improvement over the long term.
That's fantastic. So it sounds like you're saying everyone should be using baseline profiles. Go learn about it in the Android documentation and see the benefits pretty soon, especially if you update your app frequently.
Yes, especially for those frequent app updates, for sure.
Awesome. Was there anything we missed? Did you want to talk more about baseline profiles? Any other interesting stories or side tangents?
I feel good about baseline profiles. There are definitely a few other kind of performance enhancing tools that are along the same lines. Using R8 in your app, DEX optimization, and in particular, DEX startup optimization, or AKA startup profiles, is another tool that we've been working on that's very related.
So before we get too deep into some of the new specific features, can we just do a little refresher on DEX, R8, or some of the other terms that often come up in this space?
Yeah, so R8 is a piece of your app's build compilation process that converts your app's bytecode into DEX. And as part of that process, R8 is in a place where it can do a lot of very cool, potentially very beneficial optimizations to your app code and the way your app runs. So a really easy one to conceptualize is it can take a look at all of the code in your app and delete the stuff that's never used, right? Or even delete resources that are never used. Then those resources, that code is not packaged into your APK. Your APK can be smaller, your APK can be more efficient. That can lead to a lot of performance benefits down the line, right? If you have a bunch of unused code in the APK that you've shipped, then when you page code in to run it, sometimes you're paging in code that you don't actually need, right? So then that's extra work that the Android platform didn't need to do. So R8 can kind of trim up, optimize your code in those very basic ways by removing unused code, and also in much more complicated ways, actually tweaking and optimizing your code in place before it hits your APK, which then can provide some overarching performance benefits to your app. So it's a tool that does a lot of cool stuff.
Got it. So it does a lot of stuff and it operates on the dex file. And so maybe just a quick connection between how we get from Java or Kotlin code or any other code down to dex. Can you kind of bridge that gap for us really quickly?
That happens kind of at the, I would call it the build time of your app, converting the code into that dex format. Then your APK includes, this is the right way to say it, your APK includes the dex files that are generated as an output of that process.
Got it. And that's where your code is in the dex files.
Yes. So your APK doesn't include like a list of Java files. Your APK includes the dex files.
Got it. Okay, cool. Now that we're all on the same page about that. So we're talking about R8 optimizations with dex. And so the basic ones being that you can just remove code that you're not using. So
yes.
So it seems like that's been around for a while. You can, in your build files, you can enable R8 and have it strip out things that are not needed or make things smaller. So what else? What else can you do?
And for anyone that's used ProGuard, if you're a long-term app developer, if you use ProGuard for that purpose, you would use R8 for that now. In your Gradle files, instead of it being like a use R8 in Gradle, I think the line in Gradle you would add is minify enabled. So just it's kind of a surprising name for a feature that can do both minification in terms of shrinking and also optimization of your code, so like potentially rewriting or reworking your code to improve the runtime performance.
Awesome. So Nam, on the maps team, I mean, I'm assuming you also care about the dex files and the optimization performance there. And have you also done work with this part of your app?
Yeah, so code locality is super important for start performance, for launch performance, because class loading is mostly reading from disk. The common perception is that it's a bad idea to do reads from disk on the main thread, but that's what class loading is. You're reading files from disk. You're loading classes and you're also loading code. And that's where DEX optimizations come into play. It reorders the DEX. It removes code that you don't execute from the DEX. And that helps with code locality. So you do less disk reads.
Got it. And when we're talking about locality, it means that like when you're loading code, like the thing you're going to need next has already been loaded and you don't have to like read it from disk again. Is that what the locality is?
Exactly. So whenever, in this context or in any other context, whenever you read anything from disk, you usually don't just read the specific bytes that were requested. Usually the operating system will go ahead and there are ways that you can configure this, but usually the operating system will go ahead and read like a little bit more than you requested, with the idea that in most cases, just based on how people tend to write code and how many algorithms work, if you want some information from disk, you might want something that is right next to that on disk. So imagine if you have like a big blob of data and you're reading a piece of it, you might also want the next, the next string, for example, to keep it really simple. And so that operates exactly the same way with your DEX files that your code is in. If you are reading the DEX files from disk, and what we can lead into is if, say, all of your startup code is adjacent to each other, then you might have to do fewer individual disk reads to access all of the startup code. Whereas if your startup code is very separated from each other, every kind of bit of startup code, for each line of startup code, there's then 10 lines of code that's used, in a totally unrelated feature later on, and then one more line of startup code. Maybe every time you read from disk, every line of code you run, you have to do another read from disk, which this seems like it might be pretty minor, but it ends up actually adding up quite a bit in terms of just the amount of time it takes to do these seemingly trivial operations. Every read from disk can potentially be delayed or have contention or something like that and cause a little bit of delay in app startup. And those things can add up.
It sounds like too, like this could be a general optimization thing, like have code that will be loaded next, like closer so that it's already been in memory. But we both of you have mentioned startup time being a critical part here. And so it seems like that startup time is a particularly important thing that you care about where the code locality matters. It's not just a general thing where like you call a rarely used feature and you want that one to perform well. It seems like there's a lot of emphasis on like making sure that app startup it matters. So I don't know if Nam, does that make sense to you? That you care more about this? Is it more important for a startup?
Like everyone wants a fast app. Everyone wants if app to start up fast. Who wants to wait? No one. And also during startup, it's the most resource intensive part of your life cycle, application life cycle. So that's where we've been focusing on startup. Why we've been focusing on startup so much. So that's where the hard problems are. And at Google, we try to solve the hard problems.
Yeah, absolutely. There are a few different user journeys that really tax performance. Startup is usually the main one, like Nam said, the number one place where your app is trying to do the most work at once in the shortest period of time. A complicated scrolling list is another one where we start to encounter this kind of complexity, right? And we really might need to make sure that all of your frames load in time if you want to load a lot of UI really fast. But yeah, those there are usually kind of a small handful of specific performance challenging user journeys, and startup is like the one that every app needs to deal with.
So now that we know startup's important, you mentioned the term startup profile. So what is that?
So similar to a baseline profile, they have the name profile because they both contain class. In the case of a startup profile, specifically classes, but classes are methods describing what the app is doing during that time. So a startup profile contains a list of classes that are run specifically during the app startup. We can feed that list as an input into the R8 optimizer so that R8 can specifically make improvements that apply to startup, which is, again, very cool because you don't have to change anything about your app startup to kind of take advantage of this. You can basically record it, pass it to R8, and then let R8 make your app faster.
Awesome. And so what I'm hearing too is that when you're not, this is a different part of the life cycle of the app than
Yes.
baseline profiles, because we're talking about building the DEX files, which is at build time. It's not about install or runtime. And so you're talking about so how does a developer actually where does you mentioned like macro benchmark before for baseline profiles. What tools or pieces are involved in a startup profile?
Yeah, thanks for calling that out. It definitely is a different part of the app's building lifecycle. That said, it still uses the same tool, which is macro benchmark. So using the macro benchmark library, you can run your startup tests, and as an output to those startup tests, get a startup profile. Then feed that startup profile back to your app when you create your final release build of your APK for the Play Store. So that's how that would work. And as you said, it's a very different piece of the app lifecycle. That work all happens before your APK gets delivered to the Play Store. Then your baseline profile gets delivered with your APK to the Play Store and gets used once it's on your device. So they are two very different spots that we can make improvements and optimizations in the app lifecycle.
Makes sense. Yeah. What's actually kind of interesting though is because it sort of feels like you make your app, you run it to macro benchmark to understand your startup tests. Then you have to make your app again with what you learned. So you kind of have to build your app multiple times before you can actually ship an optimized startup app.
Yeah, that's true. The profile that you create for your baseline profile and for your startup profile should be able to be the same, basically the same test run. Though your startup profile, you would only want to include your startup tests, and your baseline profile, you might want to include other performance-sensitive user journeys, like those potentially janky list views are great times to make sure that you will never have a JIT compilation interrupting it. But you can actually kind of do one macro benchmark testing pass, include the one set of profiles for startup, a different set of profiles for baseline profiles, and then create your final release build with both of those profiles.
So how long have we been? How long have we had startup profiles?
We've really started publicizing it, kind of introducing it to apps, I think since maybe the beginning of this year.
So it's newer than baseline. It's newer though, right? Newer than
Yes,
baseline
newer than
profiles.
baseline profiles. Yeah.
So Nam, where are you in Google Maps on your process of looking at startup profiles?
So we haven't adopted star profiles yet. We are looking into it. So Carmen, what kind of performance improvement should we expect from star profiles?
That's a really kind of fun question because for baseline profiles, we see a very predictable performance improvement for those first launches to bring them in line with subsequent launches. It's very easy to predict. For startup profiles, we actually see extremely variable performance improvements. For some apps, they've reported 20% performance improvements, and I should pause to say, for startup profile performance improvements, these improvements apply to all startups, not just the first day of use. So we have seen some apps see really dramatic double-digit 15 to 20% performance improvements for all of their startups. For other apps, they've had smaller or more variable performance improvements. And from what I can tell, that can be based on the complexity of your app. One of the things that Startup Profiles does, I should say two major things. One is DEX locality, and the other is combining classes that are used in Startup to be one secret class, post-processed class. So combining those classes, and both of those things produce Startup improvements. From what we can tell, a simpler app is often able to take advantage of those performance improvements much more dramatically. So we tend to see bigger performance impact in kind of more straightforward apps and smaller performance impact in some cases in a more complicated app. That can also be because a more complicated app may have more than one DEX files worth of classes in their startup. And so so you naturally get less locality even if you're only looking at startup classes together. They still might have a lot of files to sift through to find the right startup classes. So yeah, I'm really glad you asked that question because this is a feature where for every app, we really encourage every app developer to incorporate it and test it and see what it can do for your app. It's difficult for us to predict the impact for every app. But like I said, for some apps, it's huge.
Awesome. So it sounds like complexity is like the size of the app, right? The bigger the app, the more benefit we should see. So Maps is a pretty big app, over 100 megabytes. So yeah, I'm expecting pretty significant improvements for us.
I think it doesn't necessarily have to do with the size of the app, and what I'm seeing more, how much work does the app try to do during startup? Does an app have a straightforward startup or a very complicated one? And so that definitely, some big apps have a small and streamlined startup. Other big apps, because they're big, also have a very complicated startup. And so it really varies based on the specifics of the app.
And when you say complicated startup, is it like the number of different code paths that might happen when an app launches based on a bunch of different factors? And so it sort of seems like if you have a simple app, maybe all the code that will run is very consistent and the same, and so it's easy to co-locate everything in one place. Whereas a more complicated app might launch, check a bunch of experiment flags about what state a user's in, and then go down totally different paths in the startup, and then therefore you can't put all the code that you want in one place. Is that kind of what your guess might be about why you see different performance improvements?
This is so new that it is a bit of a guess, but I think that does pretty much encapsulate it, right? Like how different are different startups from each other? Or are you an app that loads to one kind of clear activity, or are you an app that loads, a complicated feed where each feed item is maybe very different, and so that just takes a lot of code to show? If it's, either different between different iterations of the app startup, or just really a lot of work in your one app startup, could really impact basically how much room there is to really optimize that startup. If you just have a wide variety of things to do, we might only be able to optimize, a certain amount. But if it's very straightforward, it might be able to make a bigger difference when R8 does that optimization.
Great. Nam, have you been able to play around with this, like kind of try it out a little bit and see kind of how the tools work?
No, not yet. So we are planning to launch startup profiles this year.
Any minute now.
So you're in the middle of it with all of us trying to figure out how to use the latest technology to improve performance. So what other things, insights and performance, do you think we should talk about? Nam, is there any other interesting insights from the Maps team?
Sure. So one thing that doesn't get talked about much is the visibility that profiles give us into the startup process. For example, a basin profile or a startup profile, they tell you exactly what gets run during startup. So with this information in hand, we can figure out which code we want to run during startup, which code shouldn't run, and any surprises in between.
Interesting. So it sounds like you're saying that even if separate from the performance numbers that you can measure, just being able to look at them provides interesting insights into how your code is running.
Like the best code is code that doesn't run. That's the fastest code.
So if you see something in there that you don't think should be running, then that's something you can try and target and remove.
For example, we knows when we adopted Work Manager, we knows that Work Manager was run during startup, and the Work Manager is very heavyweight. So with Star Profile and with recent profiles, we were able to figure this out, and we added a proxy in front of the Work Manager. So Work Manager doesn't get executed during startup at all for us anymore, and that gave us a 1 to 2% startup performance improvement. So in general, I think it's a good idea to add proxies in front of APIs so you can have good control. I'm not sure if Android thinks it's a good idea, but we want control from the app perspective.
Interesting. Tell us a little bit more about what a proxy looks like. Like how are you able to on startup ensure that something is like delayed a little bit later? Just curious. I don't know if we'll talk later about whether Android likes this or not. But let's see from the Maps team perspective. What's worked well for you?
So we forbid direct calls to Work Manager. So we call our own API, and our API calls Work Manager after startup is complete. So during the critical phase of startup where we are doing a bunch of things, Work Manager is not running at all. Work Manager is running after everything has slowed down or calmed down, and that's a perfect place to run non-critical jobs like Work Manager. And we also saw a reduction in crashes just from that.
Interesting. Okay, so by delaying some of the work, you're able to have a smoother startup, and then when the device is maybe a little more idle, then you can get those jobs running. Because Work Manager does amazing things, but it doesn't need to necessarily run all the jobs immediately as things have started. It's one of its main values is about being able to do work, later when you're not needing it you're not needing something like directly in front of the user.
Right. Our main use case for Work Manager is to delete stale data that's old. So we do it daily, once a day usually. So we don't need to run it on every startup.
Got it. That makes sense. Can you share a little bit more about how you are able to delay that work so that when part of your system tries to call your proxy, that proxy is able to actually execute later?
Right. So we have a trigger when startup is complete. Once that trigger is fired, we start calling Work Manager. We start scheduling jobs onto Work Manager. And when Work Manager gets initialized, it reads from its internal SQLite database, and it starts running a bunch of initialization tasks. And that can be expensive for startup. But after startup, it's not a problem.
Got it. Really interesting. So you can shift the work to a different time so that it can start up those SQLite databases when you have a little more resources available to you. Very interesting. Yeah, Carmen, any thoughts on this from your side?
Yeah, I mean, the specific implementation detail of creating a proxy for Work Manager to do this flow, I could go either way on, but I am super, super in favor of the general idea of not doing everything just because your app has launched, right? Do the important stuff during your app startup and while you are initially showing that first UI onto the screen and everything, and maybe wait until that's done to do work that isn't time sensitive or that might interfere with that work. Super in favor of that type of workflow, however you get to it, whether it's by wrapping APIs in a local proxy or just waiting to instantiate them until after the immediate, most high priority work is over. Any of those, I think there's a few different approaches to accomplish that goal, but I think it's a really, really great way to write an app. And to go back to something that Nam said earlier, it's really important to have to be able to look at what is actually running in your app to be able to make these decisions. I've done some previous talks on systrace and Perfetto, and using the profile as a list of classes and methods is another way to actually look in and see what is running during the kind of sensitive or performance sensitive times in your app, startup, janky periods, etc. To actually, rather than guessing and reading your code and kind of feeling like you know what is running, using those tools to see what got run in a test and validate that it is what you expected. Because it's so common for app developers to kind of write code, assume that they know what is happening because of how the code is written, and then a little while later take a look at a Perfetto trace of that user journey of that startup and kind of say like, oh, whoops, like I didn't actually realize that, say, Work Manager did all this work during instantiation. It's very whenever you're talking about performance, I feel like there's a very important piece of it that is kind of the verification, the looking at exactly what did your app do. Do I understand why every piece of work happened? And if not, figure out why every piece of work happened and confirm, did I actually want every piece of work to happen at this time? And in a lot of cases, what you'll find are things like this, like, no, I didn't actually need the Work Manager work to happen before the first frame of my app was visually shown on the screen. Showing that first frame is more important. We can delay this work until after. Setting up flows like that to make sure that you are only doing the most important thing at any given time and then saving the less important work for less contentious times is, I can always get behind that type of app optimization for sure.
Yeah, well, I think what resonates to me with what you're saying is that you should be checking what your app is actually doing and then make
Yes.
optimizations for that. Because we want to make sure we're not doing premature optimizations as well. I mean, what's working for Google Maps might not work for someone else, and I don't think that the Android team is telling anyone to go make a proxy for Work Manager. It's possible that basically no app out there other than Maps needs to use it. Maybe it has to do with something specific to the way they're doing things. But since Nam is able to observe the actual behavior and how their app code runs, maybe those optimizations make sense for them. And so I think for other developers, don't go and just copy the same behavior that the Google Maps team is doing, but you can follow the principles of understanding how your code is loading and where your optimization might make sense.
Yes.
Yes. So Work Manager is just an example. The profiles that we generate from baseline in Star Profiles, they are a gold mine. The most common optimization that we do is making things lazy. We made Work Manager lazy. We made quite a bit of things lazy. Going back to the idea that we should not be executing code that we don't want. We should be aware of everything. That's where profiles help a lot for us.
I love it. One place to look at that type of work that I've been seeing across a lot of apps is dependency injection. A dependency injection framework can often, the way you're using your dependency injection can result in class is being loaded or instantiated earlier than you expect. And it's not always obvious. There's not always a clear line of code in your activity on create that maps directly to that work. So looking at your profile or a trace to see can be the way that you discover that that's happening, and then can go ahead and make that lazy.
You just introduced, I think, a new concept of a trace. Can you just like briefly tell people what's the term there and how they can go find more information about that?
Yeah, so when I say a trace in this context, I'm talking about like a Perfetto trace or a system trace. Those are kind of recordings of all of the activity that is happening on your device at any given time. So you can start recording that activity, stop recording that activity, and then load up the trace file that's created in your browser and actually see both for your activities process, the threads that are running, when the CPU, what CPUs are doing work for that thread, when that work is happening, whether there is I/O happening on disk. It's a really detailed way to see what is happening on your device at any given time. And so it's a great way to verify that what you wanted to have happen is happening.
Got it. So this is like a debugging tool that you use like with your app.
Yes.
To understand what's happening at the time you're running it on your own device.
Yeah. Mm-hmm. Yes, exactly.
Great. Nam, any other tips that you want to share with developers on any of the topics we've discussed today?
Yeah, I just want to add that Perfetto traces have been super helpful for us. With Perfetto traces, we're able to discover baseline profiles, the impact that baseline profiles can give to us. And that's how the project came about. Was we saw a lot of activity on the just-in-time compiler thread. It was running nonstop. But with baseline profiles, we announcing zero activity on the just-in-time compiler thread. And yeah, so that was confirmation that baseline profiles were working.
Very cool.
Well, that's fantastic. And so that looks like a one particular tip for understanding the connection between these two is you can look for like the JIT compiler or the JIT thread to see whether the baseline profiles were actually helping on the first app startup.
Right, that's right. Because if you have a baseline profile and the methods are already compiled, then there's no need to, the system will not discover that they still need to be compiled and start running the JIT. Yeah.
Yeah. Any other tips? I think we've been chatting for a while and we could go on forever, but want to see if there's anything important we missed or developers should know.
Yeah, sometimes it's hard to figure out which dependency to make lazy. That's where Perfetto traces come into play. With dependency injection, dependencies are injected in order. So making dependencies lazy one by one, that takes a long time. So one trick that I've discovered is that you can add a dummy dependency that just adds a trace to Perfetto. And for example, you can add like 10 dummy dependencies. And you can easily leave them inside your, between your expensive dependencies, right? And you can figure out like which one, like there was something expensive happening between the dummy dependency 3 and 4. And you can look at your code and say, okay, it was foo dependency that was expensive. And you can make foo dependency lazy. So yeah, instead of doing trial by error, making dependency lazy, you can use this trick to quickly find the expensive dependency.
Oh, that is a very cool trick because if there's anyone listening who isn't familiar with Perfetto traces, they have kind of the fidelity of a log file in a lot of ways. So you have to kind of write in your code or in platform code, there's a lot of platform trace points. You have to denote that you want to put a trace point in the file that you're viewing. So like Nam was saying, it may not be easy to tell exactly which dependency unless they're already all annotated with trace points. So this sounds like a very easy way to add some trace point annotations that can help you use the Perfetto trace viewer to identify which dependency is taking more or less time. Is that another way to say it?
Right. Yeah, basically, we're doing a binary search by adding dummy trace points. dependency trace points. And it's saved us quite a bit of time from figuring out which dependency to make lazy.
That's awesome.
And when you're adding these, like, are you adding dependencies, or are you like updating your existing kind of dependencies with the traces? Like, I didn't quite get whether can you tell us a little bit more about that?
Sure. Suppose you have 3 dependencies: dependency A, dependency B, dependency C. So with my trick, we will add 3 additional dummy dependencies. One dependency on top of dependency A, one dependency between dependency A and B, and another dependency between B and C. You can add another one after C. And looking at the Perfetto trace, like based on the order of the dummy dependencies and how long the time between those dummy dependencies took, we can figure out like which dependency is lazy and is worth making lazy.
So you're actually just saying that there are like arguments like in maybe a constructor for your dependencies or something like that, and like they are actually loaded in that order. And so if you put traces in between them, you can just see how much time passed in between each one to be able to figure out how long each of the lazy dependencies took in between.
Right. We try to automate this process using bytecode injection, but turns out that manual, just adding code manually, it works the best. It's the fastest way for us.
Got it. So once you're at the scale of Google Maps, maybe you can add additional tooling to automate this. But if you have a smaller app, maybe you can just add some of these traces yourself to be able to get the same effect. Oh, that's really interesting. That's a really great pro tip. Anything else?
I think this is great. I feel like I could always just keep talking about performance debugging using Perfetto, and there's so many different ways to use that tool and strategies for maximizing, like how to look at a Perfetto trace and guess or figure out, like what Nam is saying, figure out what is taking so long. If anyone is not familiar with that tool, I would definitely recommend just playing around with it, taking recordings of your app. Like I said before, looking through the recording of your app and kind of trying to figure out, what does each of this section of time mean? Do I know what's happening during this time? Do I want to add more trace points to figure out what's happening during this time? It always pays off to get good at using Perfetto. So I guess that's maybe the last thing. I'll cut myself off in talking about it, but it's so big. I definitely would encourage people to take a look there. Fantastic.
Any final pro tips from you, Nam?
Yeah, so it's always a good idea to get off the main thread as soon as possible. It's a good idea to have a thread that's high priority, but that runs parallel to the main thread. Generally, you don't want to run important tasks on low priority background threads, because you could have a situation where you have priority inversion, where a main thread is waiting on a low priority thread. So you want to have a friend thread that runs parallel to the main thread that has similar priority, where you offload critical tasks to it. So that's a pro tip.
Got it. So get off the main thread, even if it's not to lower the priority, just to make sure you're not on the main thread. That's the most important thing. Awesome. Well, I think we covered a lot of great stuff today. We covered using baseline profiles. We learned how those help at runtime when you've uploaded them to Google Play. We learned about startup profiles and how that optimization helps at build time, getting those things into an optimized DEX. We learned about Perfetto and systrace and how you can use that to make sure you're not prematurely optimizing, and finding also new ways to like cool tricks like Nam shared to identify which of your dependencies are actually most important to make lazy first, and so many more insights and tips. Thank you so much, Nam. Appreciate your insights from the Google Maps team, and Carmen. Always good to see you on the Android side.
Thank you so much for having us.
Thank you. It was a fun talk.